Swayam Prabha. Digital India. Educated India.
So, shall we start? Ready? Is there any enthusiasm left or is gone all? Yeah? I'm amazed that you guys have. I mean, I would be completely okay. So, let me recall what we discussed. So, you have this box, either color or whatever, handedness box, and you can decide handedness by where it exits. Yeah. And what we know is that I will just focus on. So this is a notation for electron. Okay, and this is actually notation. It is not like color. This is how it is represented. So it will be white or black, and it also could be, yeah. Now my first question is, so you have, for each of these property you have a corresponding box. Is it clear? My first question is, suppose you want to figure out, is there any correlation between handedness and the color? How will you figure this out? And what will be your method of finding out, and what is the correlation and to what extent? How will you find out that?
So we can chain two. We can chain three color boxes.
Can you draw and tell me? Or maybe you should speak there, so I have to draw. I'll do the job for you. The constraint, you can't walk with that. So tell me, what I should do?
Okay. So first we have one box. Let's say it's a color box.
What are you checking? Correlation between color
and handedness.
Yeah. What is the third property I had told, which we are now discussing? Shall we change its name to something else? It's kind of funny, I understand that. Let's keep it. So this is a color box.
Yes.
Uh-huh.
Now to the output of one, we add a handed box.
So
we'll have
but
two
there
outputs.
are two outputs.
Yeah. So to both of them, we add one handed box each.
So I have to change my place of drawing, huh?
You can draw the output down.
You want me to do? Can I just do like this?
Yes.
Thank you. Yeah. Now.
Yeah. So to both of the outputs, we connect one handed box each. So we'll get 4 outputs now.
Yeah.
And we know. And
so let's write them as.
Yeah. So now, if
these are the output channels. I am saying, okay, now.
So if it were completely unrelated, then it would be 25, 25, 25, 25 out of, on average.
Yes.
Whereas if it were related, that ratio won't be equal.
Okay, so that's. Yeah. So 1/4 each. Every 4th electron will be coming from this channel. Yeah. You agree? Or equivalently, in fact, as I told you, that we have even power to collect electrons. So I collect all white electron. Now here, so you may say that, okay, these are going together. So in fact, I can collect the same thing what you are saying. I can collect all white electron, and then I put it back here, and then I just measure whether it is coming left or right. All white electron first, and then all white electron, black electron second, and do this, all possible way you can verify to find out the statistics, correct, and that should give you same answer in some sense. So I give you the answer is as expected is 50-50, there is no correlation, okay, but it can be checked in various way. One way in which, what's your name? Ashwin Ravichandran. One way in which Ashwin told, but you can also think of many other ways. One way is that, as I told you, you can collect all white electron and put it in the hardness box and see what happens. 50% right eye, 50% left-handed. Yeah. Similarly, you can find a correlation between hardness and handedness and color, and I give you the answer that there is no correlation, okay, and it is been verified precisely by this logic. So you all agree with this logic, correct? If I do this experiment and this is the output comes, then I would say that there is no correlation between the color and handedness. Yeah, no doubt, agree everybody? Yeah, or any other way you can think of where logically it can be concluded that there is no relation between handedness and color. You perform that experiment and you will get the same result, okay, that if a white electron is taken and it passes through, it randomly deflects to be left-handed or right-handed. Yeah, great. So now I am going to, with this in mind, let us predict some set of experiment, let us tease out the behavior of electron, because we have a control now, we can sort of see how they are behaving. So we should be able to predict the outcome of the experiment, because the whole purpose of science is to predict what happens in future, correct? You want to know, otherwise what's the point of doing it, yeah? So, no, there is a point, but anyway, it does not matter. So let us say I have a 3 boxes. Okay, some mechanism as before, a monkey here to detect color, something here to detect handedness, and again a color box. They need not be same mechanism, but it is color box. Okay, so C, H and C, and suppose I take one electron and I insert, okay, and it exits. So this originally my channel was like this, and let me keep that drawing, okay, and let's assume that it is coming from here so that it can enter there, otherwise I'll so this was white, no, this is how I had written already, I mean, there I have changed, okay, doesn't matter. And now I come out of this, say R and L, okay, yeah. So I take so I insert a electron, and it say comes out white, then I put it in the hardness box, and then it comes out left-handed. So what can you conclude? So yes, so now my question is, if it enters here, what will happen? So what's the prediction? So now let's say there is a beam of white electron generated like this. What is the prediction? I am saying that prediction because in experiment there is always a statistical error, something suddenly some electron got attracted because of magnetic field and just came which was not part of your path or something, but statistically what will happen?
25%.
So you get, I would say 100% white. Who agrees with this conclusion? Cool. Who doesn't agree? I am also agreeing with it. Who doesn't agree? No one? Yeah. All of us are wrong. The outcome of this experiment is 50% of electrons come out white, 50% come out black. Is it even possible? We have followed precise logic to conclude. That's why I said predict based on the logic of set everything, correct? These boxes can repeat. If it was white electron, it will produce white electron. That is how you decide something is white. Any color box produces a white electron, it detects as a white electron. But when you have a color box, a white came out, then it went to handed box, say it was turned out to be left handed. If you put again in a color box, 50-50, 50 of them are black, 50 of them are white. So what's going on? Yeah? So electrons seem to have some way of having property that I and you don't possess. Like it's not like sort of lifelong property, something, yeah? Yeah? But it is a persistent property. If I take left-handed electron, it will measure it to be left-handed in a sequence of experiment of measuring left-handedness. But if you go through an experiment, so if a sequence of experiments, so if there was a color box here, then it will come out as W and again as W, no problem. One more box you put, it will continuously remain W. Yeah, so somehow, however, if you measure its hardness, it changes the statistics of the. So what can you conclude? What did you say about the electron? In order to conclude this, that this was 100%, what was the statement you made? No, it is persistent. You said that it is a right-handed white electron or left-handed white electron, whatever. That statement now it becomes dubious, correct? Because first time that electron was detected to be white and then it was detected to be left. Because this experiment you cannot do simultaneously. I mean, this is an experimental setup, so you have to figure out the property. Even simple property of solids and all, you cannot simultaneously figure out. You have different set of experiment and then you collect those properties. So I am not doing any cheating here. I am actually telling how a scientific experiment has to be carried out. You take a set of device and then you find different properties and then you list them. So you took an electron, checked it was white, checked it was left, and then now let me just be sure and try to check its color again, and half of them now are not white, half of them have become black and half of them have remained white. Okay? Strange, isn't it? Yeah? In fact, I will tell you even more. Now let's just do one more experiment and I want you to predict. Now don't get confused by this, we will come back to this experiment. We will just follow the mathematical logic, that what is expected, because science is based on some logic. So we are just following that mathematical logic and trying to guess, trying to predict, okay. So this did something strange, so don't get afraid, just follow the logic and try to conclude what should be true. So I will now change the experimental setup to the following, okay. So I have a handed box here. Yeah, and now I have a set of mirrors, okay. The task of this mirror is to just kind of change the direction of the electron. Yeah, so if it enters here, if it is left handed, it is moved in this direction. Yeah, there is another mirror which moves here, and there is some mechanism here, the set of mirrors that combines them to create one. So everything exists from this point in this direction. Okay, yeah, okay. Now you may ask that, okay, so how do you check that? Okay, so electrons intensity doesn't change, but how do you know that it did reflect? Reflect is just, no, this electron actually just like you reflect light. You can in fact do the experiment with photons if you want. Photons also have the same properties. So with light photon, you know how it can be reflected. So how do you know that? So what I am trying to say is that you can check that these mirrors are harmless by just sending a, say, so this is what, let's say, handedness box. So I send a left-handed electron already prepared somewhere else, and then I measure, I put a handedness box here, and again it will show that it remained left-handed. So it didn't do anything, and 100% time. Okay, so this is no cheating at mirror level. Okay, yeah. So now I am going to, so is it clear? So this mirrors and the set of mirrors here are only channelizing the beam. Okay, this is actually physically possible in every experiment. Have you heard about CERN and such labs? You have to channelize the beams for it to have hit the target. Yeah. In fact, all these things are detected by some photoelectric plate and some, you cannot catch electron. You have to just, it's just like taking pictures. Yeah. So now I am going to put a color box here. Okay, and I am going to, this is a, so point is that it takes some paths, we do not know what it path takes, but I send an electron here and I have to detect a color here. Okay, so if I generally send arbitrary electron, what will be my color statistic after this? 50% white. Okay. Now say I prepare a white electron, okay, and then I send it here and it goes through and then it enters color and it exits. What will be the color statistic of this white electron? 50-50, yeah, because you above you have, so who agrees with 50-50 and who agrees with 100%? So I have one, you have changed your, yeah, only white, okay, so 100% white, but you, huh? It doesn't look logically different from previous one, yes. Yeah, but here it changes the color, you see, it becomes white and black. I don't know, you people apply your logic and say, it's not obvious to me which logic should be applied. So there are two chance. So it's 60-40. Anybody for 60-40? No, how can it be 60-40? Two, yeah. 75-25. Yeah.
It said you have to like put a handedness box after the right side also to see how it affects the color of the electron, and then
Oh,
you
no,
can
no,
do-
you can change in any right side meaning what? You want handedness and then color box?
No,
Or
no,
you want me
after-
to put a mirror and reflect everything then enter in the handedness box? I can do this. That third color box can be the same one. It will still be the same statistic. That's a good question. The third color box, what he is saying that do I have to put somehow on the being on a left of a experiment makes it something. I mean, you can ask, all these are perfectly valid question, and this is such a complicated subject that people have actually tried to verify every such obvious questions, and though however silly it looks. So the question was that if I had put C, H and C instead of somehow I had put C here, that means if I take a mirror of this kind and bend it and enter in the C box, is the same statistic, has nothing to do with where it is placed. Okay. In fact, if you had somehow way to preserve the things that went through first two apparatus and then you traveled and went to next country and then check, same statistics. Okay. And same statistic even if you send one electron every day, so they don't have anything to do with each other. Okay, they are not kind of interacting. You say, okay, there is a being going and something happens because of this handedness apparatus does something to the beam. One electron at a time is as much time interval you want between them, same statistics. Yeah.
So I had a doubt in the top one. Would it only be 50% black and 50% white, or would we also have left-handed electrons also? Because it's
I am measuring color box can measure only color.
We won't see
After
the proper.
that, so you want to put after handedness box, what do you think will come? Once you say that this has become 50-50, the next, what will it be? 25-25? Think about it. Yeah, it's a good question. I don't know how much time I have. So for me, as a mathematician, so this setup, I would expect that 50% will come out white and 50% out black, because it is actually the previous setup, except that the beams are merged. And beams are merged in the sense it's not a beam, one electron is going at a time. But I know that it is doing something and going, okay. Finally going in that same path. The answer is 100% white. It's really strange, no? What is going on? There is no logic that can explain this, yeah? But we have eliminated. He did the experiment to say that there is no relation between R and L. See, you have to do some experiment to conclude, and we have done the experiment. There is no way.
Sir, is there some way, like when you're measuring the handedness, you have to do some kind of manipulation to find out whether it's right-handed or left-handed? So during that manipulation, is it possible that the property itself gets changed, the property of color gets changed while measuring, which is then nullified by going through these mirrors and coming through the color box?
Yes, completely agree. So what is a way to check that? I mean, which first experiment or second experiment?
In the first experiment, what we have done is we have taken the beam from color box, the white electrons alone, and put them through the handed box. So while measuring, maybe something happened to the color of the electrons while measuring the handedness, which made it again into 50-50 mixture. That's why when you measure color, it comes as 50-50.
That means you have to now make your handedness box very carefully. It should not be crude. Somehow while measuring it, it is distorting. For example, let me say whether I have understood you correctly. You want to measure a speed of some ball, and then you suppose you are measuring by seeing how much force is applied on something it is hitting, that is proportional to the velocity of it, but when it hits it, slight change in the velocity happens, correct? I mean, this is an experimental thing. So whether something like that is going on, correct? So how do you check that such a thing is not going on? If such a thing was going on, it would be possible to devise, as time progresses, some device which at least changes this statistics by 50.0000005 and whatever 49.9599999, some improvement, correct? Any effort has been done, there I think is 1,000,000% improvement into that statistic. Violation is not noticed ever. Just not possible to make a hardness box that affects this statistics in any way.
Sir, these boxes and properties are related to real properties and like of electrons. Right,
What's
sir?
the real property? I define the real property is that I can see, and hardness is the property that you can see.
It's related to experiments that have actually been done.
Yeah, I mean, you
Sir,
think
so
I'm
then-
just coming up I'm not coming up with the story. I mean, these are actual experiment done. I can
Sir-
give you reference afterwards also.
Sir, so then like.
But I am not using the language of that experiment. I am simplifying the language because, as I told you, if I use the real term, it will have no meaning to you.
Sir, so then.
What is important here is I want to point out that there is something fundamentally strange about the logic with which electron behaves versus how the class of RSIC student behaves. I mean,
Sir,
yeah.
so then maybe since electron is a very small particle, maybe how Heisenberg's uncertainty principle is there, that you can't measure both with arbitrary accuracy. Measuring one will change the value of the other. Maybe something like that's happening, which prevents us from increasing the accuracy.
That's correct. In fact, this is one kind of manifestation of uncertainty principle. And I wanted to tell you, I'll continue, but I wanted to tell you that how much care is required to conclude that something like this is true, that it is impossible to measure color and handedness simultaneously. That means, more precisely, it is impossible to make a statement that an electron has so and so color and is righty. Yeah. So this is what I wanted to point out. But let me just tell that, okay, you may, but we are scientists, have to have a proof of this kind of statements by precise mathematical setting, precise mathematical formula, something that is violated. Okay, then only you can say that this additional, because I can say that you are putting this word uncertainty principle, but well, that's because you don't know how to measure. If you measure well, then there is no problem. How do you know that it is not an issue of a measurement? And the way in which you figure out is actually you do this kind of experiment. You come up with the devices which are better and better, and then check the statistic. Even if you are able to move it by 1%, there will be no uncertainty principle, because then there is always a chance to move it by 2%.
Sir, you said that you can devise boxes which can measure in different ways. So across the different ways, maybe
This is the
there's some,
statistic. Yes.
yeah, across the different ways, if there was a change, that means it's not a fundamental law and it's related to the device itself. But
That's
if
what
there's
I'm
no
saying.
change, that means it's a fundamental law of the
Currently,
movement. So you'll not be able to.
there is no law which is fundamental in science. It is currently fundamental. Yes. Because if tomorrow you come up with a device that would allow us to tell whether electron is right-handed and white, even with the probability 51 to 49, the law will not be valid. But currently, yes, it is. So scientists after these experiments concluded that it is impossible to measure them together. In fact, but let me go a little further and tell you how absurd it is. Okay? Yeah, tell me.
So, in the second experiment, if we had a color box before we sent it into the hardness
That
box,
will decide the color.
Okay, so how would the
So the
percentage
electron you
change?
sent, electron you sent, color box exit, color as white
Yeah.
or black, I am just saying,
Yeah.
and then it will be 100%.
It'll still be 100%.
Yeah, so let's just go, it's amazing. I'll go to that experiment now, okay. Let's just, so this device, like we sort of, the experiment is going on and we make little change to this experiment. So I am telling you how you conclude that it is not possible to measure both together. So you do this experiment. So let me just write it as I have white electron coming in. So white is just a incident. You can take black electron and do the same experiment. Doesn't matter. And I have this mirror join. Now let's say in this experimental setup, I have, see these are all closed environment, you keep in mind, no? Because you have to manipulate electron, I mean, you can't just go there and do it, they will come inside your body. So you have a method. So this is a path for L and this is a path for R. Let's say it was possible to insert a wall in the path of, if there was an electron which takes this path, R electron should take this path, correct? So I am let's say I have devised a method so that I can block them, yeah, and and I can remove it whenever I want. So if I remove it, it is the experiment that I discussed, yeah. So now my question is, what are all the things you expect when I insert this path inside? So of course one thing is that the first is the output will go down by half, because the electron will come in this direction or in this direction, yeah. So output, what will be the statistics? Why? Okay, but let's say this experiment is done with these mirrors 1 million miles away from each other. Like you can keep not 1 million miles, but this experiment is done with these mirrors actually on some satellites, okay, and beams are reflected and then collected. How will this electron know, how will it affect the output of this guy here? Yes, but it has come out of this device now, and I mean this now, once it has come out of this device, it has a definite handedness, correct? But this is 500 kilometers from here, it takes a finite time to reach. How will kind of it not affect this? Try to think which path electron will take. For that set, your answer is correct. The answer is output is 50% black, 50% white. But now I claim that this is true, irrespective of the distance or any of parameter that you can put in. You want to absorb, you can absorb. You want to block them, you can block them. You can even put a mirror that just takes them out of the system. Either way, there are many ways you can design this. So you want to absorb, you absorb it. It's irrelevant. It's a well-defined system which can do that. If there is an electron coming, then it won't allow it to pass. And this you can again check by actually seeing whether it's a barrier, like like X-ray. You know that the barrier is blocking X-ray because there is nothing coming on the other side. Yeah. Maybe. So any guess which path electron has taken? It has taken both paths. I claim that if you somehow block the experiment at some point and then measure, electron is always found on this path or on this path, never found on both paths. It's not like electron is splitting itself into some two pieces and going. It's not been observed ever. This electron takes path L. So now if I had blocked here, then yeah.
Oh, so how do we know that the electron's taking the well-defined path like that? What if it's not taking any path?
Yeah, very good question. I'll put two blocks and it will not come out. Nothing will come out.
Yeah.
I'll put one more block like this, and this experiment will not have any output here. Is it logical enough to conclude that then it is blocking? Only at this point, and this can be very far but extremely minute block. It's not like a big block. You put, if the beams are very thin, so you put this extremely small, you put that extremely small, no output. Is that sufficient to conclude that electron has taken one of the path? Logically? No, I can devise an experiment that can even prove that wrong. So the problem is that electron behave fundamentally very strangely compared to any logic that we can devise. And how do you prove this mathematically? Is you come back to the original thing I started with, yeah? So you take third property now, okay? You take third property, which is, what did I call it? Hardness. Okay, let's call it glasses and not glasses. Weak eye and strong eye, okay? So electron has another property. It has either a weak eye or it has a strong eye. So you take these three property, and now it has been in past 20 years there have been experiments done which so can you recall me what was the inequality? I think it was, has anyone written the notes? So let's T is calling color, so V comma, take anything, so B, okay, B and B bar will keep, so B and the next was W bar plus N of W, and what was the thing, L bar, L of B L bar, yeah? Yeah, correct, yeah. So this was we have seen that elementary set, if you form a set of object, they have binary properties, measurable binary properties, then this inequality is satisfied. And the experiments have been done to show that a specific experiment for using these three property, that for electrons this property is violated. That is why you say, because this is a mathematical statement and it is violated, that's how you conclude that it is impossible to simultaneously call an electron black and what was strong and weak and left-handed or right-handed. It's impossible to call it like that, yeah, because it violates this inequality, and this inequality is called Bell's inequality. In fact, is the babyest version of Bell inequality, okay? The logic that we were using is the logic of what is called as classical mechanics, and violation of Bell's inequality says that classical mechanics is fundamentally wrong, okay, because what I am saying is that it's been observed that this is not a property of electron or proton, or you said there is something to do with size. No, this kind of violation is observed for a massive objects of a set which are say 20 kg in weight, okay. So I claim that if you take the set of RSIC people, and if you sufficiently isolate you guys and you study your quantum properties, I bet that you will also violate Bell's inequality, even people like us. So this is the fundamental truth of nature, that such simple logic is not followed by nature, okay, and that's why but however we can understand and predict outcome of the experiments done with them using what is known as quantum mechanics, okay. This is the reason why we need to invent something called quantum mechanics. Hopefully somebody will explain in the next few classes a basic fact about this particular form of mechanics. It's kind of beyond now that given it is 5:10 or something to explain how you even think of concluding anything about experiment done with electron if they are following this kind of logic and set of experiment. The only tool you have with them is to probe using set of experiment and a basic mathematical logic to conclude, yeah, this should happen or that should happen. Anything you do somehow doesn't work, yeah. So with that I think I'll stop. Anyone has any questions or comments?
So what are these properties?
Why do you want to know? Okay, the one simplest one to measure is the angular momentum in x direction, angular momentum in y direction, and angular momentum in z direction. These three are, you can take as a color, handedness, and weak and strong, yeah. That is one property, but there are many properties. You can measure spin. There are many binary properties of any object which you can measure, and it's nothing to do with electron. You can measure it with, yeah.
So it's like set theory wrong.
Set theory is not wrong because set theory is based on certain axioms. Once you have that axiom, it is correct because it's a mathematical logic. What it just says that electron don't follow that axiom, and we have no axiom to write down that can actually tell us what exactly is happening. So there is a fundamentally probabilistic nature in the universe. It is not something that is deterministic. There is something fundamental. That's what it says. It doesn't say that set theory is wrong. Set theory is right. If you have that axioms, of course your conclusion is correct. Anything else?
So for electrons, example handedness, can we say for sure that if the electron comes out to be left-handed, can we say it's 100% left-handed, or is it only a probability?
Meaning once it is detected to be left-handed, it always remains left-handed when you do series of experiment of any kind that can detect is left-handedness.
Okay, but that is not a probability that it is that much percent left-handed.
50, if you are given a random set, like take a cheese or some object from where you are extracting electron, your favorite object from where you can take out electron, statistically half of them will be left, half of them will be right, and it is independent of the place from where you are extracting. In fact, it is impossible without experiment to distinguish between two electrons, because the only thing you know is some charge that you can measure. Once you have that charge particle, there is some mass. So these are the problem, but you cannot distinguish between two electrons. The first place you can distinguish is find out its handedness or color. But now you note down a color, that okay, now this electron is white in color, and then you look for some other property and then again measure color. It may turn out that the color remains same, okay, but it may turn out that color changes. So it is not always true that I have peculiarly chosen properties where this color change happens, but you can choose properties where color change won't happen. I can do, for example, I put reflection by mirror, it did not change any color, but there are other measurable quantity that you suppose in between you measure its charge. Well, in principle it could have changed its color, correct, because some measurement is done. Now uncertainty in very vague way, you hear, I don't know, they are saying that okay, you cannot measure two things simultaneously, but not arbitrary two things. Some two things you can't measure, some two things you can measure. In fact, you can come up with the properties of electron which satisfies Bell's inequality. So it's not only that it is always violated, because otherwise you will get a very concrete statement, okay, then this is not the logic you follow. There are properties of electrons where this will be holding, 3 independent property where this will hold, no problem. But there are also properties of electron where this won't hold. So there is no way you can sort of apply logic and be at peace. Anything else?
If this is possible, then the counting must be negative, right? If it's violating like this.
No, counting is always, there is never a negative electron located. Only this experiment only counts how many. So the point is that counting is not negative. What is negative is to call an electron, what was this B for? Black and whatever, weak, strong. That is fundamentally wrong. You can call a, counting is, this number is counted just by ping, ping, there is a, yeah, there is a sensor.
Sir, so only properties which violate Bell's inequality cannot be measured simultaneously.
I am not making that statement, but the properties which violate Bell's inequality certainly cannot be measured simultaneously. The properties that cannot be measured simultaneously, but technically it has been, now one knows what are the properties that cannot be measured simultaneously, but I don't want to go into that. But if the 2-3 properties are given in such a way that they violate Bell's inequality, certainly you conclude that they cannot be measured simultaneously, because if it was possible to measure them simultaneously, it has to follow Bell's inequality. So I am here to give you the logic that goes behind setting up something like uncertainty. So it's also one way. If there was a set of property that violated this, certainly they cannot be measured simultaneously. They certainly follow some kind of uncertainty, but not the other way. Is it clear? Though actually it is true, but from our experiment we can't conclude that.
So in that the one up above, could we say the electrons have some sort of memory of the path? So based on that, even if they follow different paths, they know the memory. They know not to go to that thing. Yeah.
So electron has some sort of memory.
Yeah.
And
so like I don't know.
So how
do you?
Okay, this is, so remember one thing, that when you make an hypothesis in, so this could be a way in which quantum mechanics can be developed, for example. So instead of putting an uncertainty kind of thing that we can't measure, okay, electron has some sort of memory. But now to make this statement valid, you have to construct an experiment that proves it. So what is the experiment that you construct that would prove it? What your question is actually related to something called as EPR paradox. This question has been thought a lot by Einstein, trying to make quantum mechanics work against itself to say that this is actually fundamentally flawed theory. But unfortunately, I mean, I can't go in detail, but there is no way you can conclude that, because if it is true, then there is a way to conclude it. On the other hand, putting that uncertainty, you can consistently predict, you can make a model and predict what is the outcome of the experiment. So you take that as a truth. There is no real truth, correct? After all scientists do is model some physical system. It's not a fundamental truth. What does it mean to be true? It just means that, well, you do something, you apply some mathematics, you say, okay, this is the answer, and the answer comes out that. Do really electron do that? Nobody knows. Only electron knows.
Sir, unlike set theory, is the possibility that for an electron to be black or white definite, or can the electron be black and white at the same time to some extent?
So the way in which this puzzle is solved by physicists is they say that electron is in a superposition of being black and being white. But what does it mean? Requires some mathematics, and you can't develop right now. But the word they use is called superposition. But for me currently, what is a superposition? I don't know. I mean, that's another way of saying that I don't know whether electron can be black or white. But I don't know, do you know vector spaces? Huh? Who knows? How many of you know vector spaces? So what's a vector space? See, electron is always sure, either it is black or white. So in this class you have to be sure, either you know it or you don't know it. So vector space is some kind of set of vectors, okay, and it is possible to add these two vectors, just like that. Geometrically you must have added vector, no? You like put one vector and then put another vector and then there is some like that, correct? So it's some kind of vector space. So you can find a vector space such that any of this property being black or white appears as some vector in that vector space, and so it is like, you can think of it as like a plane, okay, like a plane. So the state of an electron, meaning at a given time, how physicists now interpret, standard way of interpreting, that the state of an electron is a vector in this kind of state, okay. And whenever you do a measurement, it has a tendency to either lie on x-axis or lie on y-axis. When it is lying on x-axis, you will see that it is left-handed. When it is lying on y-axis, you see it as a right-handed. But in between, it is lying somewhere in this both kind of combination space, yeah. But how to make that precise requires a little more abstraction in mathematics, yeah, because it's a vector space of states of an electron. So you have to make it, and it's not a vector space like of numbers, it's a vector space of complex numbers. They are not real numbers, they are actually, you know complex numbers, no? You have been introduced, no? Imaginary numbers, yeah. So a physicist would write that an electron E is in the state in our notation alpha left plus beta right. Alpha is a complex number, beta is a complex number, such that mod alpha square plus mod beta square equal to 1. This is how in the modern terms an electron is represented. But let's not go into this last class. I didn't want to do mathematics, so I just wanted to just chat, So Electron state of an electron is alpha, but it is, you know, you have to make sense. I mean, this is just some, what is L? I mean, this is not a vector as such. So how you have to come up with a way to represent this by a vector. Yeah, so this is how the modern way of looking at electron is like this, and it makes no sense. It makes no sense to say that is this real? Is this real? It makes no sense. Okay, you have to give up that idea. Whether electron is in a state alpha L plus beta R, is it real? Nobody knows. It is just a mathematical model, because whenever you measure, it will be left or right. And it is not electron. You are also always in a state alpha L plus beta R. Only thing is, because you are massive and you have so much decoherence, that you are always either mostly beta or mostly alpha. But all of us are always in this combination. Okay, and you can calculate precise probability of what is the chance that one of you will suddenly disappear from here, and it's a non-zero chance, and you can actually calculate, but it's so small. I mean, it won't happen before that happens. There won't be universe, so don't worry. But what you see really in the world, definitive things, is just a mere mirage. Actually, fundamentally, world is not like that. Fundamentally, world is not deterministic. So it's not real in some sense. Anything else? Purely? Meaning, the property that can be observed are purely binary. We just introduce some way of saying that it is a combination, but how do you know that electron is like that? Just because you say something mathematically doesn't mean that if electron follows that mathematics. They are binary. They are binary because in the observation they are binary. They are either left or right. I mean, how do you know about anything about yourself or something? No, you do experiment, if it turns out like that, what is there inside, who knows? They are binary. I mean, they are binary within the limit of logic that humans have. So that's it. Okay, thanks.
I would like to thank sir from our side for starting so humorously and easily to come down to our level and explain such a difficult physical situation to us. This concept took physicists themselves to very difficult to understand. We'll thank him for bringing it down to our level.